You are welcome to Joe Newton online class. Now in this class precisely, we are going to look at practical analysis, and that analysis is centered on mechanics. Of course, it is under physics. Now, this is prompted by the need and the request by many for a guide on Ssce practical physics experiment. Good. We know that work has come and gone. The next is NECO. So let's look at this um, practical analysis. We are given this. We have the rotor stand here with clamp. We have here the meter rule. Of course, I've told you that it is called a meter rule because it is 100 centimeter length. Then we have the spring here. This spring is an elastic spring anyway, an elastic material which obeys Hooke's law. Then we have mass or mass lots given to be suspended here for the experiment. Then we have the stopwatch or stop clock depending on the one you are using. Then we have the pointer attached to the spring using the plasticine. The pointer is there for accuracy in measurement. That is why the pointer is there. So we have the pointer here. The pointer is here for accuracy in measurement. For accuracy in measurement. So this is the pointer for accuracy in measurement of the length of the string when extended. That's what the pointer does. Okay. Then, for the stopwatch, there is whenever we have the stopwatch here is for measurement of time. Then with the meter rule here is to measure the length, perhaps the original length of the spring and the new length or final length when loaded with masses. Of course, with that two variables, you'll be able to deduce the extension in each case or interval of the experiment. Now, this is mechanics. Okay, usually in the Ssce exams, we have mechanics, we have optics, and we have electricity. Sometimes we have thermal experiment, that's thermal physics anyway. Now, this is the observation table. Take this to be the mass lots given. The variable masses, we have 50 grams here, 70, 90, 110, and 130 respectively. You could have more than this, you can have different other mass lots depending. Then number of oscillations will be given because you have stop clock here or stopwatch. There is oscillation, that's simple harmonic motion involved. So number of, but this case will be vertical oscillation. Vertical oscillation. Now, number of oscillation is involved, and that number of oscillation could be any stipulated number of oscillation. For in this case now, in this analysis, I'm taking 20, for example. It could be 10, it could be 15. Good. Now, this is the typical table, that is observation, where we record table of observation, where we record the result of experiment from the procedure. Now, this is the mass in gram. Remember to put the unit. Then before the table completely, we have other observations, observable records. First of all, we have to measure the initial length of the spring. That is the original length of the spring. I call it L0. Let's take it to the X in centimeter. The original length, let's take it to the X in centimeter. Then we have to take, in each case, when we suspend the mass, we now have the extension. Of course, you know, when you load the spring, because the spring is elastic, the spring will extend, the length will increase. So as the length increases, you have a new length. So I call it L. Yeah, in a question, it could be labeled L1 or any other thing. I call it L. Why the original length is L0? This original length is constant throughout the experiment because that's the original length of the spring before you start the experiment. And those constants are not necessarily needed to be recorded in the table column because you normally record the variables in the table. Why the constant for evaluation or observation or guiding of the experiment is recorded somewhere ahead of the table before the columns in the table. Okay, this parameter here, L, is, for example, I take for example, for the initial one, assuming that my initial experiment, that my initial value is L is equal to Y, for example. So for me to get my extension will now be L minus L naught. So which means analytically using my variables here, it will be, in each case should be my extension here will be y minus x, taking y and x as figures obtained from the experiment. So that is it. L, the new length minus original length gives the extension. Then, which will be a positive value anywhere. So this is the extension in the column. Some experiment or question might ask you to have a column for your L, that's for the new length. Then you include it in the column. It might be needed in the question. All you need to do is to add a column L before the extension. Then you do your evaluation of subtraction before you get the word extension. Then T. T is the time. Now, this question, you might be required to, first of all, suspend this, take the original length record, then put a given mass. Let me start from this now, maybe 50 gram mass. When you put 50 gram mass, it will extend. I record my new length. Then the question might ask you now, because you have a stopwatch here, to ask you now to do what? Oscillate it vertically, displace the spring, the loaded spring vertically. That is, displace it vertically. That gently displace it and leave it. Then now, read with your clock. When you do that, it will oscillate to and fro. The movement will be to and fro like this. That's the oscillation. It will be up and down, to and fro. When that is being done, you'll be counting with your stopwatch or clock for the number of oscillations required. So in this case now, if I have 20 oscillations, remember in calculating, counting the number of oscillations, you should allow the complete oscillation for you to count. For example, each to and fro makes one complete cycle or oscillation or vibration. So that is it. Up and down 1, up and down 2, up and down 3, up and down 4, up and down 5, and so on. And you should be careful in this case. It is different from simple pendulum where it is easy to read. But in this case, at the initial stage when the mass is not much heavy, like at the mass of 50 grams, you have to be careful because the tendency is that the oscillation will be faster. So the smaller the mass, the load, the faster the oscillation, the oscillation. But the bigger the load, the mass, the slower the oscillation. Which means, what does it imply practically? When you suspend 50 gram mass, there is tendency that it will take less time to reach these 20 oscillations. When you suspend 70 gram, it will take more time than that of 50 gram to reach 20 oscillations. So you see that as the mass is increasing, simply the time of oscillation, that the time of oscillation to complete that number of oscillations is what? Increasing, because you are loading the spring the more, thereby making it to oscillate slower as it is being loaded. That's the simple analysis. You should know this principle. It will guide in your result. When the result is what? Okay, or experimentally valid, you should know. That is it. So because the masses are increasing, you should just know that the mass, take note of this, that the mass is directly proportional, that the load is directly proportional to the what? To the period, to the time of the oscillation. So as the mass is increasing, the time is what? Increasing. That is why we have in Ohm's law that F is proportional to what? Extension. Of course, you know that F is equal to KE. So this is the guiding principle, that is from Hooke's law, that the extension of an elastic material, provided that the elastic limit is not exceeded, that the extension is directly proportional to the applied force or load. That is the condition. So that's what this is obeyed. That's Hooke's law. That's what I've just stated here. F is proportional to what? E. F is the force, E is the extension. Then F equals to K. If where K is the what? Elastic constant, or the stiffness of the material, or the force constant, or the what? Spring. And perhaps at the end of this experimental analysis, plotting graph, getting your slope, you will be asked to make an evaluation. That evaluation will be tilting towards getting the what? The force constant. Yes, there must be an evaluation to get that constant, because every experiment has a fundamental principle or constant that is going to be what? Determined. So quickly, let me tell you what will happen here now. So as we're increasing this, which means in this extension, our E will be increasing. So here is what? Increasing. E will be increasing. increasing. So for time, the time will also be increasing. That's the trend. Or this is how we make judgment in the marking of the practical exams. Increasing once you follow the trend. The quantity or the quantity or the variable, the figures or the ratio or the interval with which it increases doesn't necessarily matter in the experiment because it can't be uniform for all the candidates or threats. So here, once the period time is increasing, the period of oscillation, which is equal to the time for that number of oscillation over total number of what oscillation. You know, period is the time per unit oscillation or per unit cycle. So t over 20 in our case, since our n is 20 here, it should be t over 20. If n is 10, it will be t over 10. That is each column here, divided by the number of oscillation. You get the period in capital letter T, also in seconds. So this one will be increasing too. It will be increasing. Then for t square, this is evaluated with calculator. It will also be increasing. So the trend across this column is that all the quantities here will be increasing with what? The mass. As the mass is increasing, every other thing will be increasing. So our M increases with our what? It that to our what? Extension. Because that mass is the force. The mass here, the weight of this mass is the force that brings about the extension. So our mass is proportional to the extension and it increases with the time of oscillation as well. Thank you. So with this now, if you are asked to plot, maybe plot a graph of, you might ask to plot a graph of t square against m, or a graph of e against t square. So expect graph like this for analysis. If you plot the first one, from this first one, you might be asked to, you get your slope, then get a slope, get your slope s, then evaluate k is equal to 4 pi square over s. From the second graph, you get your slope s, then evaluate k is equal to 4 pi square times slope. This will give you a constant. Then another likely question that might be asked here is for you to state Hooke's law, which I've stated, and you might be given a question to calculate that has to do with maybe work done by an elastic spring, work done on this spring or potential energy stored, which is given as what equals to what? Half Fe or half Fe or half Ke square, because you should know that F is equal to what? Ke. So that is it. The work done by this spring, work is equal to 1 over 2 Fe or 1 over 2 Ke square, in case you are asked such question. Then for your precautions, what are likely precautions here? The precautions to be taken here is very simple. The first one of the precautions that you avoided parallel error when taking readings from the meter rule and the what? Stopwatch or stop clock, especially on the meter rule. Avoided parallel error when taking reading from the meter rule. Then it must be stated in past tense, and you have to mention the instrument. Another precaution here is that you make sure that this spring is at rest when after loading the mass before taking the reading. It has to be at rest before you take the reading. Then you now proceed to oscillation. You don't take the measurement of the length of the spring when it is oscillating, when it is dangling or oscillating. So it's a precaution that this thing is at rest before taking the reading of the length. That is it. Again, you can also say that you measured from the rigid support to the point of the word of the spring. These are likely precautions one could state there. And you avoid drought when taking the word oscillation, and you displace it gently to avoid irregular oscillation. Thank you for paying attention to this class. I believe this can help you as you are preparing for examinations or you are preparing your candidates. Do not forget to subscribe and click the notification button if you have not done so that you'll be updated each time I upload new videos on physics and mathematics. Kindly share this. You can drop your question or comment there. Join me on my Facebook page as well at Jonathan Online.